The latest trend in the world of construction is something you might not expect. Architects are designing tall buildings using massive timber beams that proponents say are much more environmentally friendly than steel and concrete. NewsHour Weekend Special Correspondent Megan Thompson recently traveled to Milwaukee, Wisconsin to see a 25-story building that will be the tallest mass timber project in the U.S. when it's completed. This story is part of our ongoing series, Peril and Promise, the challenge of climate change.
In downtown Milwaukee, Wisconsin, a new luxury apartment building is rising in the upscale Easttown neighborhood. The project is called Ascent, and to most passing by, it probably looks like a typical high-rise construction site. Turns out, it's anything but.
To say it's very unusual is a massive understatement.
Tall buildings like this are usually built out of steel and concrete, but this one? It's being built mostly out of wood.
How unique is this project here in the United States?
Oh, it's unprecedented from an approval standpoint, from a fire testing standpoint, from a design and engineering standpoint. There was so much innovation in this project.
Tim Gauckman is the managing director of New Land Enterprises, the development company behind Ascent. Building it out of timber was his idea. Constructing with wood isn't new. We've been doing it for eons. But this uses a new technology called massive timber, or mass timber for short. Mass timber, which is surprisingly fire resistant, has made it possible to construct wood buildings that are larger and taller than ever before. In fact, when the 25-floor Ascent building is completed next summer, it will be the tallest structure of its kind in the world.
What made you say, I want to build a high-rise out of timber?
Once you go into a building that has exposed wood, you understand right away. It's beautiful and you feel great in it. It is fast, it is precise, it is light, it is clean.
The first 6 floors, which will house a parking garage and pool, are built from steel and concrete. So are the elevator shaft, stairwell, and foundation. But the 19 upper floors are constructed from gigantic mass timber beams, columns, and boards.
This is relatively new, especially in the United States. It's more common in some parts of Europe, especially Scandinavia.
David Core is a civil engineer and director of architectural engineering and design studies at Northwestern University. He's currently studying the structural properties of mass timber.
So when we're talking about mass timber or tall timber, what's new here?
This would be a 2x4. This is sort of a familiar piece of timber. If you tear down the walls of your house, you would find small pieces of wood like that behind the walls, and that's what carries all the load in your house. So this is an example of mass timber. It's important for people to understand that this is a very small part of something that would be very large. So there'd be a single layer on the bottom, and then a layer of glue, and then another layer of glue. It's kind of like making a cake out of wood, where the glue is the frosting.
This material is called cross-laminated timber because each layer is glued crosswise, which makes the material stronger.
So it's kind of like plywood on steroids.
That's exactly right. It's structural scale plywood on steroids.
These huge slabs can carry massive loads, but inch for inch, timber's not quite as strong as steel and concrete, Core says. So it's not great for wide open floor plans with no supporting columns. And there won't be a wood skyscraper as tall as the Empire State Building anytime soon. Mass timber was first pioneered in Austria in the 90s and is gaining popularity in the United States. In 2013, the U.S. had 26 mass timber buildings. Today, there are 576 built or under construction, and several hundred more are in the works.
There's a lot of appealing attributes to mass timber. One of them is the sustainability aspect. So one of the downsides of concrete and steel is they have a lot of what's known as embodied carbon.
Meaning production of steel and cement is very polluting, contributing somewhere around 15% of global carbon dioxide emissions. On the other hand, trees are what's known as a carbon sink. They suck in carbon and lock it in. And studies have shown replacing steel and concrete with timber can lower a building's global warming potential. But cutting down too many trees can contribute to global warming. And some environmental groups are wary of an increased demand for wood.
There's still a lot of questions, and the jury is still out on whether or not it can be achieved sustainably.
Kieran Kennedy directs People and Nature Policy for the Sierra Club. She worries that a logging boom could lead to the loss of a critical tool for fighting climate change. Because once they're cut down, trees stop actively sucking in carbon and lose a portion of the carbon they stored.
The question that we and other folks are wondering is there enough forested area to both be able to sustain mass building and protect our forests? or are forests better left intact as a natural carbon sink?
She also notes our forests are important wildlife habitats and natural buffers against flooding and erosion. So Kennedy and some other environmentalists are hesitant to embrace mass timber just yet.
This is European white spruce, so this is sustainably farmed.
Jason Korb is the architect of the Ascent building. He says the team was careful to source their wood from sustainably managed forests.
Had you ever designed a timber building before?
Never once. We went big.
What was that process like?
I think we knew about 5% of what we needed to know when we started in March of 2018. And I liken it to going to graduate school for 2 years.
Part of what Korb had to figure out was how to get the city of Milwaukee to approve his plans. The tallest mass timber buildings right now are in Europe, including the very tallest, an 18-story tower in Norway. But the tallest buildings in the U.S. are between 7 and 10 stories, in part because American building codes have been slow to catch up. Architect Jason Korb spent more than 2 years proving his 25-story building would be safe, including answering the question often on people's minds: how will the structure hold up in a fire? The Ascent team worked with the U.S. Forest Service to do extensive fire testing, the first of their kind ever conducted. 9 wood columns were burned in a furnace for 3 hours straight at temperatures reaching more than 2,000 degrees.
Mass timber doesn't burn. It's very different from your standard 2x4. It chars.
That charring layer actually acts as insulation, protecting the rest of the wood. The Ascent columns charred and held up. The columns were designed a few inches wider to allow for this fireproofing layer. It was just one of the many new things architect Jason Korb had to do.
The amount of pre-construction work that needs to be done in a tall timber building is pretty much like nothing we've ever seen, especially in a residential building.
That's because in traditional construction, all the holes for things like plumbing, wiring, and ductwork are drilled in the steel or formed in the concrete as the building is going up. But in timber, all of that is cut beforehand. So Korb and his team had to create a precise digital model.
The building was modeled down to the last screw. Those files are then fed to the manufacturer, and they are laser drilled to a tolerance of about 3 millimeters.
Korb says at the time it cost less to import the wood from Austria than if he bought from a North American supplier. So the 3,700 precisely cut pieces were shipped to Milwaukee, where the construction team is now putting them all together.
And we're currently installing the columns from level 19 to 20.
Chris Johansson is the project manager for C.D. Smith, the construction company building Ascent.
Heads up, heads up.
Each enormous column is hoisted by a crane. Special glue is pumped into the hole. Then the column is carefully put into place.
There's not one column, there's not one beam, one floor panel that is interchangeable. So we have detailed plans, a lot of color coding, and a lot of communication to ensure that we're installing things in the right place.
All the wood is treated with a waterproof coating, and the building's glass facade will protect the timber structure inside, where about 50% of the wood will remain exposed. Any wood outside is protected by sheeting, a water-resistant sealant, and insulation. Assembling the structure is comparatively quick, at least 4 months faster than if this was all steel and concrete. And Chris Johansson needs less labor for this part, about a quarter of the workers. He says the work is also much less strenuous and dirty.
One of the guys told me that his wife is questioning if he's going to work because he's not coming home covered in concrete.
Fewer workers and a faster job mean big savings on construction costs. But the wood itself isn't cheap. Architect Jason Korb estimates it's about 10% more than what you'd pay for concrete in Milwaukee. But that price might start coming down as the supply in the U.S. grows. The Canada-based company Structurelam opened its first U.S. plant this summer in Arkansas, a few hours from Walmart's headquarters. That's because Walmart is building its new corporate campus out of, you guessed it, mass timber, 2.4 million square feet of office space.
It's not just my hope, but my prediction is that it's a matter of time until the United States overtakes the rest of the world in production, in assembly, and in the use of buildings like this.
From the avalanche of interest Tim Gauckman says he's gotten in Ascent, he could be right. He's already rented nearly 10% of the units. Normally, he wouldn't have even started leasing yet. Ascent is slated to open next July.